All right. Well, let's go over a couple of announcements just to begin. Homework number 4. The deadline for that is today, and I know I told you it was going to be due before class, but I'm just such a softie that I'm going to push back the deadline to 5 p.m. So if you still were struggling to finalize homework number 4, you can submit it by 5 o'clock, and I absolutely promise that the deadline is not going to be extended beyond that any further. Okay, now homework number 5, present worth analysis. That one is due on Monday at the start of class, so noon for homework number 5. And as I announced previously, the midterm exam is going to be on Wednesday the 3rd of March, and so that's a week from today. And the way it's going to work is that at 11:30 the exam PDF file will be available on Blackboard, and you'll have 2 hours to work on that. You can print it out if you like and solve the exam on what you've printed, or you can just have the exam on your screen and write your calculations out on a blank piece of paper. You're likely to have a question on that test where you have to use Microsoft Excel, so what you're going to do is you're going to upload both your hand calculations as a PDF file and the Excel file to Blackboard before the deadline of 1:30 p.m. If you miss that deadline, you get a 0 on the test. So don't keep working till 1:29 and assume everything's going to work out great. You absolutely have to upload that by 1:30 p.m. I'm not going to have any sympathy or flexibility if you miss that deadline. All right. Now, you're allowed to use your previously solved homework assignments, your class notes, any hand notes that you've taken, textbook. You can use those resources, but what you're not allowed to use during the test is outside websites, and you shouldn't collaborate with other people. And just to remind you of the stakes, if I catch any sort of collaboration, if there's any cheating or inappropriate collaboration on the exam, then you'd get a 0 on that exam, and in fact I'd give you negative points because my philosophy is the penalty should be greater than the original value of the assignment, and therefore there's an incentive to not cheat. So if you have any questions about these announcements, feel free to reach out and contact me by telephone or email or calling me on Teams. I'd be happy to help you out in any way that I can. One other announcement that's not on the screen here, but it is on the course schedule I shared with you on Monday, and I mentioned it on Monday. Our class meeting on Friday of this week is going to be pre-recorded, and I'll email you the link for Friday's class later this afternoon. Okay, so today we're going to talk about future worth analysis. Before we move on to that, does anybody have questions? Okay. We've talked about the future worth method before, but now we're going to talk about future worth analysis. And before we do, let's review this phrase decision criteria. It's critically important that you understand what is meant by decision criteria. And just to give you an illustration of a decision criteria, for present worth analysis, the criteria is that when you discount cash flows to the present at the minimum attractive rate of return, then you choose the alternative with the highest non-negative present worth. So in other words, the decision criteria is how you know which alternative to choose. It's a statement that summarizes whether you should go for one alternative or the other. So it's not simply enough to solve a spreadsheet and find the present worth of each alternative, but I want you to explicitly state which alternative is best and why. So you have to show an understanding of how to make decisions on these economic calculations. Not just the ability to do the calculations, but how to apply them and make a decision with it. Okay, so that's the decision criteria for present worth analysis, and we'll talk about today what's the decision criteria for future worth analysis. Now, before we do, I just wanted to give you the thought that maybe you should begin preparing for the exam. And part of the exam is going to be concept questions. The majority of the points will be related to problem solving, but some of them will be related to a fundamental understanding of underlying concepts. So for instance, I may ask you a short answer question like, what is the purpose of present worth analysis? And so think, when I show you each of these questions that we're going to go through for a moment here, just ask yourself, would you be able to provide a meaningful response? And what I'm looking for usually is 3 or 4 sentences. I don't want a lengthy paragraph, and I'm not looking for 1 sentence. In most cases, these short answer questions, if you're too brief and terse, that is going to be an indicator to me that you don't have the depth of understanding that's looked for on this. So the purpose of present worth analysis is to identify which of the alternatives is most profitable. And so the purpose of the analysis is for decision making. Okay, now what about this one? What is the assumption? What assumption is built into the LCM approach? Now let me give you a warning. I'm going to wave my arms. I'm waving my arms because this is an important warning. So I hope everybody who's participating in today's class will really make note of what I'm about to tell you. You should answer the question I ask. Don't answer a different question. It seems straightforward, right? But let me just give you an illustration. If I ask this question here, what assumption is built into the LCM approach? My experience tells me that maybe about a quarter of the class is going to say, LCM stands for least common multiple. Now, does that answer the question? If the question is, what assumption is built into the LCM approach? So that's the question. If you say, LCM stands for least common multiple, now what you say isn't wrong. It's true that LCM stands for least common multiple, but that's not the question I asked. So I'm waving my arms to give you the warning. Answer the question that's being asked on the exam. Don't just say something else that's related and correct, but not addressing the specific question here. Okay, so that's my warning, and I even waved my arms. So the answer to this is the assumption that's built in is repeatability. The assumption that in future cycles of the cash flow that you'll be able to purchase the item for the same price and that you'll receive the same revenues in subsequent cycles. So in a word, the assumption that's built in is repeatability. Now it's okay if you tell me in your answer, it's okay if you say the assumption built into the least common multiple approach is the assumption of repeatability, meaning that the costs and revenues in follow-up cycles is the same in the first. You know, it's fine if you want to define what LCM stands for, but don't think that just because you said something that's not wrong, that means you get the points. You get the points for answering the question. All right, which factors influence MAR? Okay, so the wrong answer to this question is MAR stands for minimum attractive rate of return. That's not what I'm asking. I'm asking what factors influence MAR. And so the factors that determine what is the interest rate that's set as the minimum attractive rate of return. So those are factors such as the cost of capital, meaning how much does it cost your company to borrow money from banks. That could be one factor that influences the MAR. The availability of projects. It could be whether your organization is for-profit or a non-profit organization. So if you go back, there's a slide where I talk about the different factors that determine what value is set for the MAR. Last concept question for today. Why is there sometimes a difference between nominal interest rate and an effective interest rate? Okay, so the wrong answer to this question would be just to write the equation for the effective interest rate. Okay, so if you write the equation, that's super, that you know that that's the question that applies. I mean, it's not nothing, but it's not the answer to what was asked here. So what's asked is, how come the nominal and the effective interest rates are sometimes different? And the answer there is that if the interest is compounded more frequently than once per year, then the effective interest rate will be larger than the nominal interest rate because of compounding. So the Y is related to compounding frequency. Okay, so hopefully that gets your mind juices flowing and just thinking about preparing for the exam. It's great to go through the in-class exercises. That's a fine way to prepare for the exam. It's good to go through your previously solved homework assignments. If you're really a glutton for punishment, you could go through some of the old lecture videos. Maybe doing that for Excel would be the most bang for the buck, so to speak. So remember that when we were doing present worth analysis, the three methods we've talked about to handle different useful lives is the least common multiple approach, which is summarized with the diagram on the right side there, where you're doing cycles and they both terminate at the same time, and then that's how you're able to compare the alternatives. Seth asks, will part of the exam require Excel? And the answer is yes. Contract services approach is where you are lengthening the shorter of the two alternatives by renting the equipment after it wears out for the shorter. And then early termination is where the longer of the two options is truncated by selling it early. So using the market value of the equipment, and so instead of taking the revenue for the last few years, you would just take a lump sum payment equivalent to the salvage value or market value of the equipment. So each of these was discussed in detail in our prior lectures. And today what we're going to talk about is a related method called future worth analysis, and it's just kind of the same as present worth analysis, except for we're going to, instead of taking all of the cash flows to time 0, we'll take all of the cash flows to some future year. And the same rule applies, that it has to be the same duration to compare two alternatives. So that is, if you have one alternative that is 6 years and another one that is 9, you have to make it so that they both end at the same time. So you'd have to use that same repeatability tool, or you'd have to use contract services, or you'd have to use early termination. They can't have unequal lives. And sometimes you'd use future worth analysis when you have a large project that requires many years of construction. So if you think about the construction of a new airport or a roadway, there are some projects that can't be built in a single year, or they can't just be purchased off the shelf. It's going to take a long time to build them. And so in those cases, it may be advantageous to find a future value. And I'll show you kind of an illustration that makes the case of why. And a special subset of that are projects where you expect to build it over time and then sell it. And so it may be that a contractor is building a house over some time period, and then at the end of the time period where the contractor's been taking the construction loan, then they're going to sell it to the ultimate owner of the property, and so there's going to be a future lump sum for all of the periodic expenses that have been incurred over time. And so then you'd need to know what is the lump sum sales price that should be collected. Decision criteria. So it's similar to present worth analysis, except for instead of moving the cash from the future to the present by discounting, in the case of future worth analysis, you're compounding the amounts. So you're compounding the amounts to the future using the interest rate of the MAR, and then the way that you choose between one option or the other is you pick the alternative that has the highest non-negative future worth. So same idea as before. You want the options to be profitable, and then you choose the most profitable of the two. All right, so here's what we're going to do for today's in-class exercise. We're going to start with this comparison of two options for dredging a shipping channel. So there are these boats that scrape the sea floor and will shoot sand to try and make one part of the ocean a little bit deeper than another. And they sometimes have to do that to get ships into port. And so option A assumes that we're going to do a complete rebuild of a shipping channel that's going to take 3 payments of $220 million, including a lump sum payment here at the present. So there's some sort of a mobilization cost or initiating the project of $220 million. And so 3 of those, and then after it's completed, there will be revenue over time that's generated. And then the other alternative that we are going to be comparing that to, option B, you'll notice it only lasts for 3 years, but you pay $225 million now and it's immediately available. Now they end in different years. Option A is 9 years long. Option B is only 3. And so we're going to have to do that thing where we repeat the cash flow diagram. And so my suggestion is that first of all, what you should do for this in-class exercise is I'm going to pause for a moment, and I'd like, hopefully you've got this printed out. Draw on top of option B the cycles of repeating to get you through year 9. Okay, so in other words, create a cash flow diagram, and then together we're going to start up Excel and go through the future worth method to decide option A or option B, which one is more profitable. Okay, so I'm going to pause for a second and give you a chance to write on this diagram, what does the cash flow diagram look like for option B if you're using repeatability? Okay, so let me just see if I can do a quick sketch here. This will be interesting. All right, so what you would need to do is you need to pay again in year 3, and then that gives you, let's see here if I can draw. This is a bit awkward. Then that would give you revenue here. And that's the same height. Imagine it's the same height. It would give you the 3 years of revenue afterwards. And then you'd need to buy it again at 6. And then that would give you 3 more years of revenue following. So this is what your cash flow diagram should look like. And now let's use the future worth method to find out which alternative is better. Okay, so start up Microsoft Excel. I'm just going to do a quick print screen, and then I'm going to paste that into Microsoft Excel over here on the side. I'm doing print screen just so I can glance at that diagram as I set it up. Hopefully you're able to watch this video at the same time as you do the calculations yourself. Alright, so our interest rate for this problem is 7%, as it says on the paper, so 0.07. And now we're going to have year, and remember for the future worth method there's a reverse time column, because we want to know how many years is it to compound into the future. So I'm going to say years until year 9. Okay? And then amount and FV of amount. So this is the process that we use for the future worth method. Now we're comparing 2 options, and so there's going to be option A, and then over here is option B. And so let me copy this, Control C, and paste Control V, because we're going to look at option A and option B and see how things compare. Feel free to interrupt if you have any questions as I'm going through this. This is really important, being able to solve these on Excel. If you're not yet comfortable with Excel, then that means you need to practice. That's the only way to become comfortable with Excel, is just using it. Alright, so year 0, 1, we need to go down through 9. By the way, you should already know how to do this. We've done the future worth method before, so this is something I hope you already know how to do. So if you're working ahead from me, that's fine. Don't feel like I need to be holding you back, because if you've done the assignments and you've done the in-class exercises until now, the future worth method is something you're already proficient at. Alright, so how many years is it until year 9 when we're on this row? So I'm going to do equals 9 minus whatever year we're on. And so then this is going to be the n that we use in our formula, because we're compounding things into the future. So anytime there's a future worth problem, you need to have the time and the reverse time column. Okay, now we'll put in the cash flow for option A. So it is negative 220 million. And I recommend, let's change that to currency. And those pound signs just mean I need to make the column wider. Okay. So it's 3 payments of 220 million and then 55 million after that. Okay, so that's the cash flow for option A. And then the cash flow for option B is going to be 225 million in outflow at time 0. Let me change that to currency. Okay, and then 35 million. And how many of those? There's going to be 1, 2. So there's 1, there's 2. And then in year 3, we've got a cost of 225 million and a revenue of 35 million. So I'm going to say equals negative 225 million plus 35 million. Okay, so the net amount in that year is 190 million. And then I've got 35 million 2 times. And then again in year 6 is that thing where it's both the cost and the revenue. So I'm just going to do equals and point up here so I don't have to type that in again. That'll return the amount that was there. And then following that in 7, 8, and 9 we have $35 million revenue. So 35 million. And I'll drag that down through the remainder of the cash flow. So here's our cash flow table. Let me format all of that as currency. Okay. So any questions so far to the point where we're at? Let's see, I see a question here. I didn't hear it. Oh, that was from before. Any questions? All right. So future worth. Let's start putting in the future worth formula here. Equals FV is the pre-formatted formula, and it says that it wants the rate, and then it's going to ask for the number of periods, and then we're going to skip over the payment field and put in whatever amount it is into the field that's associated with the present value, because we're treating each one of these row amounts as a lump sum present worth that's being compounded into the future. Okay, so first, the reference to interest rate. Click on the cell for I and press F4 to get the anchoring, and then comma. NPER is the reverse time column, because this amount, 220 million, we're trying to get it to time 9. So how many years does it have to go to get from 0 to year 9? It's got to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's why we say this is our number of periods. And we skip over the payment field because it's not that there's 9 $220,000 outflows. There's only this one that we're considering for this row. So we're going to click equal minus of the amount. Remember that minus sign is because if we don't, Excel automatically will change the sign for us. And so we know it's an outflow in time 0. It's going to be an outflow at year 9. We don't want it to change the sign of it. Okay, so let me change the formatting though because I'm seeing red. All right, so 220 million at time 0, when you're compounding it, when it increases by 7% each year, by the time it gets to year 9, that has compounded into 404 million. Now I can drag this formula down through all of them, and let's calculate a total. So using the equals sum function means that this option, option A, costs $659 million. Okay, Now let's do the same thing over here for option B. So equals FV, and refer to the rate, and the N is the reverse time column. Skip over the payment field and the minus of the applicable amount. I typed in an extra key here. Okay, there it is. Give you a moment to look at that. I have to make the column a little bit wider to see it all, and I'll change that formatting style. Okay, now I'll drag it down to get the calculations for each other row, and then I'm going to do equals sum of this column, so that I'm going to find out the total future value for option B. Alright, now let's think about decision criteria. Which option should be selected? Alright, if do nothing is an option, then do nothing, because neither of these alternatives is profitable. But if we must do something, then select option B, because option B is the least negative of the two alternatives. And so the question is, is this the sort of thing where you have to dredge the shipping channel because maybe the country relies on getting cargo through that port? And if this is the government picking up the tab and it's not a for-profit company, then it may be the case that we just go ahead and do it even though it doesn't pay for itself. Maybe there are other benefits that haven't been accounted for. But if the do nothing alternative is one of the choices that we have available, then do nothing. Okay, so here I've stated both cases, that if the do nothing option is available, then choose neither of them because they're both negative. But if you have to do something, meaning that if a money losing option is on the table, then option B is better because it's the least negative. Okay, so any questions about this first problem? So let's think about how this would look to the grader. We can make a few changes to spruce this up a little. If we're thinking about communication, and communication isn't just writing papers for English class, it's also formatting spreadsheets and other technical documents to make them as easy to understand as possible. So one way we might make this a little more appealing is by adding in these borders. So let's do all borders, and now it has a little bit more of a dividing structure between columns and rows. And maybe it would be nice to center these. See how year is to the left and the numbers are to the right? Well, what if we centered it? That looks kind of nice. That's great. We could center these labels as well. Center those labels. Now, the option A is referring not just to this, but option A also is referring to this column. So let me show you something that you can do. If you select both of these, then there's this wrap text option, and what it'll do is it'll smush two cells, it'll spread the one cell across the width of two. So see how right now this is two distinct cells? Well, if I do this wrap text thing, then it makes it clear. Wrap text. Am I thinking of something else? Merge and center. I'm thinking of merge and center. There it is. Alright, so we've merged the two cells together, and we can put the outside border. Now it's more obvious that option A is talking about both of these columns apply to option A, and then option B, merge and center. We'll put a border there. Alright, so that looks a little bit better, and maybe we could make this bold just to make it clear that it's the better alternative. So I'll put in some additional annotation. Option B is the least costly alternative. Just kind of highlight that of the two, option B is better, and why? It's because it's less costly. So the two options is better. Explain how you know which option is better. Well, we kind of did that here where we said it's the least costly alternative when all of the amounts are compounded to the future. Option B is least costly. All right. If there aren't any other questions, then let's think about this one. All right. So what I'd like you to do is read over this problem and draw the cash flow diagram for both option A and option B. These are two different investments that are available to your uncle. We're trying to figure out what's the value of option A and what is the selling price that should be considered for option B. So first things first, just read this and prepare a cash flow diagram for both alternatives. I'll pause for a couple of minutes, give you a chance to sketch that out, and then I'll show you what I think that cash flow diagram should look like. All right, let's take a look at the cash flow diagram. I've just sketched that out and it's on the screen now. So if we look at option A, the idea is that you pay $250,000 at time 0. Then there are 11 equal payments of $33,000 per year. And what we know is that your uncle's minimum attractive rate of return is 4.5%. So that's the lowest interest rate that can be accepted. The other alternative that's under consideration is that you pay some amount now, so we don't know how much, that's why it's a dashed line. So there's a present value that's not known, and then in exchange there are 11 payments of $25,000. Okay, so that's what our cash flow diagram looks like. And now let's consider the case. I've started a separate tab on the spreadsheet file. All right, so let's find first of all the future value of option A in year 11. So if we're going to be moving those amounts from the years that they're indicated to a future value, let's find out what is that future value. And we can use the same form that we did for the first problem. And by that what I mean is the same like column titles. So I'm just going to copy, actually I'm going to copy all of this. And if you have done that, you can do the same. So I'm going to just do Control-C, or you can use up here copy. And then I'm going to paste, move over to the next worksheet, and you can do paste. But I want to paste also the formatting. Is if, oops, I need to do that again. Is it still selected? Okay, so it's still selected. So to make sure that the widths are correct, I'm having some issue here. I'm not sure what's going on. Okay. I'm having an issue with my screen. Well, let's do this the hard way. Let's make sure that those columns are wide enough for the amounts that we're going to put in. All right, so translating the cash flow diagram to the cash flow table. So here's the cash flow diagram. So option A, first of all, is $250,000 at the present. So I need to define years through 11. And then the reverse time column, it's not going to be years until year 9, but it's going to be till year 11. So it's formula will be 11 minus the year that we're in. Okay, now the amounts. So for option A, the uncle is paying $250,000, so minus $250,000. One more zero. Is that right? 250,000. Let's do all of these formats as currency. All right, yeah, 250,000, and then receives 33,000 each year through the entire cash flow sequence. Okay, so the value, oh, by the way, we need to change the interest rate as well. I copied over from the previous problem, but the interest rate for this one is 4.5%. So let me adjust that to 0.045. All right, so now the FV equals FV, and the rate that we're using is this 4.5%. N is the reverse time, where we want to know how many years into the future it needs to be compounded. Skip over the payment field with this double comma in the function, because the amount that we want to be there is this, and we have to do the minus sign because Excel would automatically change the sign of the function. And so 250,000 compounded into the future at 4.5% per year has an equivalent value of 405,000 if you move it to year 11. Okay, and we drag that down through the entire cash flow, and then we're going to have the total future value by doing a sum function. All right, so the question asked, what is the future value of option A in year 11? So what if your uncle, instead of getting all of this over time, 11 payments of 33,000, and instead of having to pay up front 250,000 at time 0, what's the equivalent amount as just a single lump sum in year 11 to both the inflows and the outflows? So that is this, $51,046. So question A, the future value of option A in year 11 is $51,045.64. Okay, so we've answered part A. Now part B says, how much should you pay, how much should your uncle pay for option B so it has the same overall future value as option A? Okay, so we know in option B that the revenue coming in is $25,000 a year. So we can put that in. The revenue coming in every year is $25,000. That we know. But what we don't know is how much he needs to pay for it to have the same equivalent value in the future. So, for example, what if he only paid $100,000? Let's just use that as a guess for now. Maybe he has to pay $100,000. Okay, we're going to do this future value function equals FV of, here's our interest rate, and the N, skip over the payment field, the minus of this amount, and we'll do it for all of them. And again, we'll do the total, so sum of this column. All right, so this would be a pretty good investment if your uncle only had to pay $100,000. So your uncle's paying $100,000 and then gets $25,000 a year for 11 years. And how do you know that's a good investment? Well, the lump sum future equivalent is $183,000. What this question is asking is, how much should your uncle pay? So this is the payment amount. So I'm going to put this in yellow just to make it clear that the amount entered in yellow is how much your uncle pays for option B. So if you pay $100,000, Then this is the outcome. I'll do that one in green because for Marshall University Thundering Herd. The amount entered in green is the lump sum future value of the alternative. All right. So the question is asking, how much should your uncle pay so that this amount is the same as the future value of option A? So here is the future value of option A. So what we want to do is keep changing this until the number in the green cell equals that. Since I've gone with color codings, maybe if I'm in for a penny, I'm in for a pound, right? Oh no, I don't want to change the text. I just want to fill it with, all right, some sort of a yellow. So I'll say the amount in, what color is that? It's like a dark orange or something. I better pick a color I know the name for. Never really learned my colors, I guess. Blue? Yeah, I know blue. The amount in blue is the lump sum future value of alternative A. All right, so let's start changing this. What if it's 150,000 that uncle has to pay? That was too many. 150,000. Okay, that would bring it down to 102. What if it's 200,000? We're getting closer. Oh, that's too low. So as you might expect, rather than just iterating manually, we can iterate in an automated way with goal seek. So across this top ribbon, choose data, what if analysis, goal seek, and our goal is we want this to be equal to a value of 51,045 and 64 cents by changing this amount that's paid. Okay, and it thinks for a second, and it's found it. It's found that it's $181,768. And so for part B, the question was asking, how much should your uncle pay for option B? So your uncle should pay $181,768 and 66 cents to make the value of option B equal to the value of option A in terms of a lump sum future amount in year 11. And there we have it. Christian asks about the goal seek. Let me demonstrate that again. I think before I did the goal seek, it was at 200,000. Okay, so what we did is data tab, what if analysis, goal seek, and our goal is we want set cell. This is the one that it's going to be looking at. So set that cell to a value of, now I have to type in the amount I want it to look for. It should look for 51,045 and 64 cents. So it's going to keep changing this, the amount in that cell. It's going to keep changing it until it finds this cell equal to the amount that I've just entered. And I click OK, and it goes in and solves 181,000. All right, 12:49. We are out of time for today. We barely made it through that one. Let's take a look at these announcements before we part ways. The homework 4, remember, because I'm a softie, is due by 5 o'clock today. And homework 5 is due before class on Monday. And then we'll have our midterm exam next Wednesday. And then one last announcement. Friday's class is online. I'll send you the link. That's it for today. Thanks, everybody. I hope you have a good one. I'll see you next time.